Number five, question on proportions. A banquet for 34 people would cost $1,600. All right, so that's pretty simple. And assuming that the per person price stays the same, how much would it cost for 44 people to attend? And so the proportion is $1,600, dollars for 34 people. And so question mark dollars for 44 people, right? And so you have 1,600 divided by 34 is equal to question mark. If you're a fan of algebra, you can call it x and divide by 44. Now, the formal procedural way to do this is to cross multiply 1,600 times 44 is equal to 34 times the question mark. And therefore, the question mark x is 1,600 times 44 divided by 34, which is $2,070.59. All right, so that's a formal way of doing this. A formal meaning it's of the form. Okay, and many of you probably will feel more comfortable understanding the meaning of what you're doing, instead of just following a procedure, and that's okay too. So here's another way of thinking about this, and many of you may have already solved this problem doing it this way. If $1,600 is for 34 people, you divide 1,600 by 34 to get 47.0588. This is the price per person, right? After all, $1,600 is the total price for 34 people. So then using this, you can just multiply this number by 44 people, and that will get you the same amount for the total cost. Okay, and that's perfectly acceptable. And in fact, this is even more meaningful because now you know how much it costs per person. Number six, what is meant by the statement correlation or association does not always mean causation? Okay, now let me emphasize this. This is one of the most important takeaways from this course. Did you hear me? Okay, if you forget everything else in this course, I hope you don't, but if you do, try to remember this. Okay, anytime when you have two quantities related to each other or associated with each other, there is a pattern between those two quantities, calling x and y. Just because they are correlated does not mean that one is the cause of the other. All right, so let me give you an example or a couple of examples after I explain what this is. Okay, and so you studied this first in chapter 1. In fact, on the very first lesson on fallacies, this was one of the fallacy types. And then we studied this back in chapter 5 when we talked about statistics. Okay, so the picture is if x and y are two quantities that are related to each other, okay, either they both increase at the together, like when x increases, so does y, or as one goes up, the other goes down. So as x increases, y may go down. Okay, so that's another a type of correlation. More technically, this first one is called positive correlation. The second one is called negative correlation. But in each of these patterns, you see y is somewhat related to x, right? But that correlation or association of y with x does not mean that y is a result of x or x is the cause of y or the other way around. Okay, so for instance, and I have given you many examples throughout the course, the longer a child watches television, the lower the GPA is. So there is a clear correlation. The longer TV watching and lower the GPA. So this is one of those negative correlations. The number of hours of TV watching increases, the grades go down. But this does not establish for sure that TV watching is the cause of lower GPA or the other way around, which is even more ridiculous. That is to say, when the student's GPA goes lower, that causes the child to watch more TV. And here's the thing. The truth is, most likely there is a cause, an underlying cause that is producing both of these changes. Okay, so for instance, in this case, it may be that there's something else that is causing the children to watch more TV and lowering their GPA. Okay, and that certainly is a possibility. Maybe certain family situations where kids are left to watch TV all the time because there is no There is no supervision of these children, and because there is no supervision, their GPA is not as good. Okay, so there may be other sociological aspect to it. And by the way, it may be that it's true that the more TV time a child has, the lower GPA. The fact that maybe watching more TV would lower a student's GPA. That could be possible. All we are saying is it does not guarantee or it does not imply automatically that TV watching is the cause of the lower GPA. Here's another more recent example. The number of accidents went down during the COVID-19 crisis, and so did the average, and then the average speed of cars went up. Okay, so the number of accidents went down, but the average speed of cars went up. Okay. Oh, great. That means in order to avoid car accidents, we should speed, right? Because the high speed is clearly causing the accident numbers to go down. Or because the accident numbers are going down, that's making people go faster. Is that right? No, of course, this is not a causal relationship, right? And there is clearly, in this case, an underlying cause. All right. So what do I mean by this? There is an underlying factor, a cause, that is allowing the number of accidents to go down and the number of the speed of average cars to go up, and that is just the volume of the traffic, right? Because people are just basically staying at home, during, especially during the complete lockdown. And that means that the freeways are empty, and so people are tend to speed, and the number of accidents is going down because there are few drivers, and of course that means we have fewer accidents. Okay, so it does not mean that, again, it does not mean that the high speed is causing lower accident rates, or the fewer accidents are causing people to drive faster. Okay, that is what we mean by correlation, not always establishing causation. Very, very important. Okay. Number 7, briefly explain the difference between quantitative and qualitative data. Okay, that's a pretty simple one. Quantitative means it's a numerical kind of data where calculations actually make sense. Okay, so if you have a bunch of numbers like the income or the time spent on certain activities or somebody's age or the number of times a person has visited some place or something like that, you can find the average number, right? If you can find the average number and the standard deviation and so on, that is quantitative data. Qualitative, on the other hand, is not something that you can manipulate by mathematical calculations, such as colors, person, gender, genre, favorite movies, etc. Okay, these are not numerical, and it does not make sense to add up a bunch of genres and divide them by the number of genres to find the average genre. Okay, so that would be qualitative. Number 8, describe each sampling method. So you have random sampling method, convenience sampling method, systematic sampling method, and stratified. Random just means that any member or every element or every person in the population has the equally likely probability of being picked in the sample. This is the hardest one to perform or to implement, but it is the best one to avoid bias. Convenience, on the other hand, is probably the worst method of sampling. Convenience sampling is whatever is convenient, such as just walking around the neighborhood and talking to a few people, or going to your classroom in just one of your courses and talk to people in that class. Okay, if you walk into a calculus class and you find out that a whole bunch of students actually like math, and you therefore bunch of students in general like math, and so that's not a very good sampling method. Systematic means that there is something systematic going on, such as picking every 100th unit that comes out of the assembly line, or asking every 10th person that appears in the class roll, or something like that. Okay, that would be, if you have a systematic way of choosing who gets to be in the sample, that is called a systematic sampling. And then finally, the stratified, it's based on the word strata or stratum, and that means grouping or tiers, like TIER, that kind of tiers. And so it's picking a certain number of people or subjects from each subgroup, like picking 10 families from each state, or picking 5 people from each age group, and so on, so that you can make sure that every subgroup is represented in the sample. That would be called the stratified sampling method. All right, number 9, what is the main difference between an observational and an experiment? Okay, another important distinction for you to remember. Right, observation or observational study is a study where the researchers do not at all influence the subjects, okay? And you do not treat them, or you do not treat some of them, um, and you don't divide the subjects up into a control group and the experimental or treatment group. You simply make observations or take measurements, okay? So for instance, you can measure how fast a certain tree grows or certain plant grows, right? And you just keep data, and that would be called an observational study. An experiment, on the other hand, is a study in which subjects are actually given something, or something is done to the subjects. Typically, the subjects are split into at least 2 groups. One is called the control group, and usually, if there are only 2, the other is called a treatment group. The treatment group actually gets a real medicine, or whatever that treatment is, whereas the control group doesn't get anything or gets what is known as a placebo, right? Um, using the same analogy or same example of plant growth here, maybe you want to compare how plants grow in the sun compared to in the shade. Okay, so then the sun would be the real quote unquote medicine, and the control group will be the plants that are not placed in the sun. Okay, and that way you can check if the treatment called the sunshine is actually going to help plants grow more, and so on. Okay, so notice here you are actually doing something to the subjects, in this case, a bunch of plants, and you're dividing the plants into 2 different groups. Obviously, in the case of plants, you do not have to have a placebo, because plants do not have a placebo effect. Okay, it's not like some plants say, wow, I'm taking something. It may be real medicine or placebo, so I should be getting better. There is no psychological effect on the plant. So sometimes a placebo is not necessary, but if the subjects are human, oftentimes a placebo is necessary. We'll come back to this later. Okay, hopefully that clarifies the difference between an experiment and an observational study. Number 10. By the way, I should mention one more thing here. There is a third type of study, and that's called case-controlled. Case-controlled study is sort of in between observational and the experiment. Okay, case-controlled study. And so what this is a study in which the researchers do not actually influence the subjects, but they do use 2 or more clearly divided or split groups. Okay, so an example would be something like asking the question, we may have talked about this, but can seatbelts save lives? Okay, so you can't do an experiment in which you ask 100 drivers to always wear seatbelts and drive around, and another group of 100 drivers never to wear seatbelts and drive around, and maybe you can provide placebo seatbelts which really don't work. Okay, there is an ethical problem with that kind of a control study. So you can't do the control study, okay? So because you cannot tell people to do something unethical or unsafe. But you can observe the people who wear seatbelts and who don't, because people themselves can decide whether to wear seatbelts or not. And you can compare these 2 groups of drivers. Okay, so that would be called case control study. It is sort of like the experiment in the sense that there's more than 1 group of subjects. And it is observational in the sense that the researchers do not give any influence to the subjects. All right, let's go to number 10. You are interested in how many calories a community college student eats every day. You randomly choose 100. Remember, by the way, go back and maybe highlight this. You are interested in something. This is what you're trying to find out, okay? And in order to find that answer, you choose 100 community college students and check their daily calorie intake. The average was 27,000, oops, that would be a lot, 2,700 calories. Now, this is an observational study because you didn't divide the subjects into two groups, one to make sure they eat a lot and one to starve or something. But identify the population, sample, parameter, and the statistics. All right, you remember a population. This is the entire group of people or the subjects that you want to study. In this case, it is a group of all community college students. Okay, basically you can say general community college students or students in all community colleges. That is a population, okay? Because you want to find out how many calories a typical community college student eat. It doesn't say specifically these 100 people. So what are these 100 people? And that's your sample. So your sample is always a subset of the population, okay? So the population is all community college students. The sample is the 100 students you picked, right? And the parameter is the number that you are really seeking, in this case, your question was focused on how many calories, right? And so the answer to this question, the daily calorie intake of a community college student, that is your parameter. Okay, now you'll never find the parameter. Even after a careful study, nobody will ever know the parameter, technically. But what you can do is to estimate that using methods of statistics, okay? And the statistic, in this case, singular, statistic is the average of the sample. This is called the sample mean of 2,700 calories. This is the statistic, and you use statistics from the sample to estimate the parameter, which is unknown in your population. All right. Number 11, find the mean and the median of 30, 40, 25, 55, and 10. The first thing you should observe on this one is that this is not in an ascending or descending order. So you'll have to reorder this before you find the median. The mean is pretty simple. You just add up all of these 5 numbers. And because there are 5 numbers, you divide the sum of 160 by 5 to get your mean, which is 32. Now, to find the median, which is the middle value, you don't want to just pick whatever appears in the middle, okay, unless it's already ordered. This one is not ordered, so let's order them from the smallest, 10, to largest, 55. In this reordered list, you can see what the middle value is, which is 30. That's your median. If you had 6 numbers, or an even number of figures, okay, then of course there is no middle one, right? And so what do you do in that case to find the median? If you have an even number of, data numbers, whatever, then what you do is to pick the 2 middle ones and then find the mean or the average of these 2 numbers, okay? And that's how you find the median. All right, so this concludes the first part of this, and we'll go start with number 12 on the next part.